Hey, good morning, good evening, folks.
Hello.
How's it going? I know
Great.
Stefan mentioned he wouldn't make it today because he's on a plane right now, but I think Clive wanted to drop in as well, so we'll give them another minute before we kick
Okay.
things off. Hey, David, how's your summer been? I know it's been a few weeks since we last caught up.
Yeah, it's been fine. How are you guys doing?
Not bad. Participating in a lot of cool new projects, tracking a lot of new things. Yeah, I've been working with the Intuit team here in Srivathasan, just like helping them brainstorm and ideate how to bring their library into open source. So I thought that would be a great transition. So one of the different areas that I think are really going to tie interoperability of MLOps tool together is if there's a coherent library and that codifies the different tools that an enterprise or a team can use for specific MLOps stages. And this was something that I saw a lot at AWS, and Srivathasan and Intuit was actually one of my customers. So they have built some of these internal abstraction libraries for their data scientists and ML engineers. And they were very interested in open sourcing the project, and they've just started getting around to that. And I think this also is a good opportunity to see what are the synergies between what gets developed between vendors and providers with also like what gets built internally in terms of these abstraction layers that the platform engineering teams for MLOps will build for their data scientists and ML engineers. So with that, I'm going to hand the mic over to Srivathasan to introduce himself and let him explain what this library is that they've recently open sourced.
Hello, good morning, everyone. First time meeting all of you. Quick intro, my name is Srivathasan. I lead the ML platform engineering team at Intuit. And my team is responsible for all the ML workloads and the productionalization of these workloads at the company. And we've been a customer of AWS for a long time, and I was a customer of Alex's product in AWS SageMaker operators on Kubernetes. We're big time into Kubernetes, and we're using Kubeflow and a lot of the other Kubernetes ecosystem as well. So one of the products that we recently open sourced just like a couple of weeks back is an MLOps toolkit for mix and match tooling, which we use internally in production as well. And we thought it would be useful for the industry. So we just open sourced it and wanted to share it with all of you and get your feedback and thoughts on what it is and where you think it might be useful. Okay.
Just enabled share screen. Sorry if you didn't see that earlier, Srivathasan.
Sorry, can you repeat that, Alex?
I just enabled share screen, so you should be able to see it now.
Okay, yeah, I see it now. Just give me 1 second. Should be able to see a PowerPoint slide. Okay. All right. So the library we've just open sourced is called mlctl. It's an MLOps library for mix and match tooling of the various ML stages. So our thesis is that the MLOps is not just one thing, but it's made up of a lot of these smaller steps, which are broadly categorized into data collection, processing, feature engineering, labeling, model design, training, optimization, then deployment and monitoring. We see a lot of these stages happening in various forms at Intuit, and it's not always linear, and there's always feedback loops that kind of go into different aspects of this life cycle and keep kind of looping back. So it's like a shoots and ladders game, right? Like you start with data collection, processing, you do some feature engineering, train the model, and then decide that these features are not good enough, and then kind of goes back. And at some point of time, it escapes from that loop, and then you go into optimization, and then you deploy the model and start monitoring the models. There is no one way to do this, and so at Intuit, we use a variety of tools, some some internally homegrown tools, some open source libraries, and some coming from vendors. For example, we use SageMaker training and hosting. We also use Kubernetes for training and hosting. We also use other open source libraries, like for example, Kubeflow. We use Kubeflow for our orchestration and so on. The question is, how do we put all of this together in a consistent experience for our data scientists so that they are not exposed to the sprawl of these different tools and have a consistent experience? So that's where we were thinking of how the cloud journey has been in the last 5 to 10 years, where cloud infrastructure has been orchestrated by Terraform. So you actually abstract out a lot of the underlying complexities of the clouds. Kubernetes clusters are being orchestrated by Rancher and Tanzu and the like. And data pipelines, similarly, you have Snowflake, Prefect, and so on. So our thought process was, what if we have a library which provides a standardized layer to do all the MLOps processes? Like you want to launch something, you want to update and see what's going on, and you want to have connectivity between the various systems in the big gate. And that was the genesis of this library called mlctl, which if loosely modeled behind the naming behind after kubectl. And the reason for this naming is that we think of this as the control plane for ML. And this is what as a platform, we offer to our customers who are the data scientists, and we allow use the mlctl to abstract out some of the underlying complexity over there. So what the mlctl provides is a consistent platform SDK, which then compiles the model code into an universal MLOps container and provides enterprise data versioning, metadata tracking, artifact storage, authn and auth, and all of the niceties that an enterprise needs across all the big 8 on the right. And we've integrated this with our Kubeflow pipelines. So our Kubeflow pipelines essentially invokes mlctl, and then training happens on Kubernetes, deployment happens on SageMaker. At our data scientists, they don't know the difference. Essentially, we could enable something like this, where you have multiple projects within the company who are using their own set of tools for certain things, and we are able to abstract a lot of those into a single interface. So right now we've open sourced this. It's very, very fresh, and we're actively working on making it generally available for SageMaker. And we're also working on adding beta support for Azure ML and Kubeflow pipelines. So while the library within Intuit is fully functional with a lot of these interconnectivity. On the open source version, we had to kind of strip out the intuitisms and the company specific things. So that's why we are taking it step by step, and first providing the support for SageMaker and then adding support for the other systems. This is the GitHub, and there's quite a bit of documentation already there, but as I said, it's still early stages. We are probably a couple of weeks away from 0.1 kind of a release, but it's the basic things work on the mlctl library. Any questions or thoughts or feedback?
No, it seems cool. It's a great name. I'm surprised nobody over all these years has chosen that yet.
That's what I said too. I said that so many times in all our meetings.
I suppose it'd be good to see like an example, just so I can really visualize how you would use mlctl. Have you got one that you could walk?
Yeah, we did a few recordings together actually over the last week. Srivathasan, do you have any of those handy?
Yeah, just give me 1 second. I need to stop share and pull the link again. Yeah, we did a couple of recordings. I'll show one where we use mlctl to create a standardized ML project, and then there is one more where we show how we use mlctl for deploying to Azure. There you go. Can you hear the audio from that, or is it not? Okay.
No, not me anyway. You might need to reshare in Zoom, don't you? Is there not an option to include audio when you share your screen?
Use mlctl for the MLOps process.
Here now.
A notebook into code that can be properly handled in GitOps and deployed using the library. So mlctl is a CLI right now, and if you use something like help, you can see that it has a variety of different functions: batch, hosting, and train, and those are what's built into it today. So by starting mlctl project, you run mlctl init, and you can put a project name, a project slug, so that's the project folder that it'll fall into, and then a quick description, and then version number, and then from there it packages it as the code. So it's a boilerplate. I have another demo one that also just created right before this.
So just to add some more context, mlctl allows to create a boilerplate project. So there are a bunch of templates that we think are really good starting points for someone to start their ML journey. Like if I don't know anything about ML, I can just do mlctl init. I'll get a scaffolding that I can then build my ML code on. That's what we're showing in this demo here.
And within this scaffold, you can see a number of different files, a lightweight README, and then some setup Py. These are all related to the Python packaging system that we abstract on top of. And the two core files that users are going to leverage are the train.py. This is just a basic template, and then a predict.py. So in the train.py, if you look at a notebook that's used to train a model right now, this is a very basic decision tree, and it essentially pulls data from a local CSV file, extracts some of the columns, and then trains a model using a decision tree from within scikit-learn, so not XGBoost. And then from there, it saves the model and puts it in the local directory. So we're going to adapt this real quick to serve within the mlctl template format. So I copy all the imports right now, and then the training function ends up being fairly straightforward. So I can put this here And then there's some opinionation in terms of how the tool was set up. But here, I'm going to define a main file instead as the entry point and copy in the code. So you'll notice here that I also put in something called TA. This is a new library that we put in called a training adapter. And this training adapter essentially handles all the bindings with the underlying infrastructure that will run your training job and your prediction job. So on AWS, this handles the place where SageMaker will mount your data, where it will save your model artifact, and where it will basically pull things like even the environment variables. So instead of this read.csv into a Panda, within the training adapter, there are certain helper functions like input as data frame, and you can specify the channel, so training, test, and then also validation. And then from there, it will actually load the data as a data frame. And we have other wrappers that we're working on for other data types. And then from there, it still leverages the standard training input, whatever the library that you use. But also on top of this, we add in several other pieces of abstraction as well. So if I put in the other lines of code, there's logging a metric function. So using a training adapter, there's a log metric, which will then save it to the underlying provider infrastructure. So SageMaker also has a built-in experimentation system. And then also you can extend this to tools like MLflow, where if you have it added on within mlctl, when you provision the job, this will automatically send the metrics over to mlctl, so MLflow as well. So after that, you can save the model as a file format. So using this artifact path function, when the file name is specified, it returns the actual path. So this is very different from Azure to SageMaker to what you want in Kubernetes or even something like Kubeflow pipelines. And then when you run the pickle dump, it will save it into the right spot. And then finally, you could do another function like log artifact. And if you just pass in the object that you have from before, this will actually propagate this through within the tool to MLflow, or once again, the existing infrastructure provider. And actually, these two can be merged as well if you just want a one-click command of logging the artifact. And this shows a really quick version of how to package this model together within mlctl. In this video,
the couple of other things that we will add to this video is also after what Alex showed there, there is another step called mlctl build, which actually packages the container.
I think it's in the next video.
Oh yeah, it's in the next video.
I think the Azure one shows this clearly.
So the steps are: you create a project. We start from you do have nothing. So you create a project, and you can write your code, and from there you can actually start training your model, building the container for the training based on the target. So if it's SageMaker, it'll be a container that can run on SageMaker, versus if it is Kubernetes, any container can run on Kubernetes. So the same SageMaker container will run. And in this example, we're going to show how it runs on Azure.
So in this video, I'm going to show how mlctl leverages YAML specifications, in other words, declarative spec files, in order to do job deployment. So for an mlctl project, you're always going to have a provider YAML, and this specifies the underlying infrastructure that the job will deploy with in terms of resources. This is normally provided by your ML platform team. And then for the actual job that's being run, you also have a train YAML and a predict YAML. So in this case, for a training job, I can specify the job name, the job type, and then various hyperparameters. and then finally the input and output data for the job. So my ML platform team actually already spun up a set of resources for me, and essentially it's an Azure ML Studio environment. Azure provides a cluster that you can provision in terms of the number of resources, so number of VMs, and also the size of the VMs on behalf of the user. And when we go to MLCtl, there's a few things that have to be done. So in the previous video, we showed the code that created the scaffold template. From there, you can do MLCtl train build, and this essentially builds the container on the underlying VM. So this is done locally, and what we'll see here is that I already created this image a while ago, and it takes a little bit to actually build because it's a Docker. And I can show you the outputs of when the job ran. It's pretty standard. It packages all the different dependencies and leverages all the different libraries that need to go within the container. And then it finally tags it here. And
just one thing to add there, this uses a standard Python packaging mechanism called setup tools internally. That was the background behind the setup.py. That's where you specify all the dependencies that your model needs, like different pandas, sklearn, and things like that. And MLCtl understands that, and then as part of MLCtl, we also open sourced a way to extend the setup tools to build actually Docker containers. And there's an internal library called Baklava, which does that magic. And that's what you're seeing here.
Of course, once you have the image locally, you also need to be able to push it up. So MLCtl train push actually deploys this container onto the repository on the cloud. Once again, that takes a few minutes. So I'm going to show how it's already done here. And we can see it basically pushed to the Azure Docker repository that we're going to use. And once we actually have that all going, we're going to then deploy this. So it's MLCtl train run, and this run job actually will then get launched on the Azure environment. So once again, I've actually done this in a separate window, and this shows all the different configs and files. And if I actually then go to my cluster, I can see these runs that happen on the environment. So this was all launched via MLCtl. And essentially here, by clicking the latest run, I can see that it launches with the MLCtl metadata. It packaged our different libraries, specified the backend. It passed in the input data set that we had, and you can see it running in totality. And from there, it even outputs the model back in this pickle format. And if we go to MLflow, where we have this also going, MLCtl demo, we can see the Azure ML runs that happen here. And these are the artifacts that were created within the MLflow environment. So this is logging from Azure ML to MLflow. And this is all handled by the MLCtl experience, integrating the training adapters and making it streamlined for your data scientists and ML engineers, so that they always have one common API spec, but the platform engineering team can route all the different models to the places that they want to store it, and also be able to route the jobs to the place where the team wants to actually deploy the job for training and prediction.
So to double click on that, the MLCtl train run, that command is exactly the same whether you're running it on SageMaker, Kubernetes, Azure, or in the future Google Cloud, any other thing. we provide these adapters, ability to write these adapters. So there's an interface with which we are able to write these adapters. We've written the training adapter. Alex was showing the beta version of the Azure adapter that then provide the glue between the underlying infrastructure and the data scientists. So irrespective of what underlying infrastructure is used now, the API remains the same from a data scientist perspective. They always do MLCtl train build, MLCtl train run, and provide the appropriate configurations, and then things run behind the scenes. Any feedback?
Okay, yeah, no, it's interesting. So you've got like the CLI and also like a Python SDK then.
It actually is a Python SDK, so you can embed it into Kubeflow pipelines, and that's exactly what we do at Intuit. We embed the Python SDK within our Kubeflow pipeline files.
All right, okay. So the Python SDK is inside the Kubeflow pipeline, so it's not the other way around. Or...
Yeah, right now it is triggering the jobs, and we have a way for it to embed it within the pipeline. We're open for thoughts on how we can take it forward. Okay.
So when we were showing this to another customer, they basically had said they'd be really interested in seeing something like MLCtl be almost a packaging mechanism for components. So in a KFP component right now, you can create one as a platform team and then share it within your organization. That often abstracts away the boilerplate code. But once the actual data scientist or ML engineer wants to add in their code, you essentially have to build another component on top of an existing component, which introduces a lot of, KFP really hasn't handled this yet. So with MLCtl, the platform team can provide that boilerplate code and then package it as an extendable component. And then the user just throws in their code within the MLCtl format. This can then run within KFP, or it can run in an ad hoc manner, the way that we saw in the CLI in the demo.
Sorry, I think I missed the, what exactly does the baklava do? And is that something you guys built, or is that a public?
Baklava is another library that we just open sourced along with MLCtl. So they both work well together. So this, it's an independent library, but it is well integrated into MLCtl. So what Baklava does is it builds these universal ML containers. So you can do like a Baklava train, predict, and execute, and we are adding a few more entry points into Baklava. So it actually provides taking a raw Python code, it builds a Docker container that can then run at scale. So we use Baklava internally at Intuit to build the container that runs our TurboTax models, for example, which are taking in like hundreds of millions of calls every day during the tax season. Our data scientists have no idea about what web server is running and how it is being served, right? What is the scaling that's happening within the container? How is my Python code being scaling to hundreds of millions of calls every day? That is handled by Baklava. And what we've done here is we built it on top of the setup tools Python packaging system and added an extension to setup tools to build Docker containers. And that's what this one does. If you're using MLCtl, Baklava is a dependency that MLCtl takes. So it's it will be transparent. So MLCtl train build essentially does all of this. But Baklava is an independent library in its own right, and it can be used for building containers for SageMaker, Azure, and other targets.
It still downloads, like for each package, I still get the actual tar gzip file for each package. Okay.
Oh yeah. You get that, and then it gets packaged into a container. And if it's meant for hosting, for example, if you want to run it on Seldon, you need to have a certain interface for the hosting. So you need to have an health check, and you need to have certain paths. All of that is what Baklava puts in into the container, so that the container responds to all the hosting environments interfaces.
Got it. Thank you.
Hey folks, I need to drop for another work meeting, so sorry about that. I had a hard stop at 8:30. Thank you so much for allowing the opportunity to share work, and thanks for your time. Really appreciate it. You guys can continue. You guys can continue, and Alex can give you.
Thanks, Srivathasan.
Sure,
Really
thanks.
appreciate you joining on.
Thank you.
Thank you so much.
So I think as the world evolves here, this type of abstraction SDK in MLOps is this terminology that I'm toying around called MLOps orchestration. So when we've talked about orchestration in the past, it's been workflow pipeline management and being able to construct a DAG. That's correct, but I think what we've also seen is that the workflow orchestrator itself, so whether it be Airflow or Kubeflow pipelines, seems to not be a definitive winner, which is fine. And it matters a lot more about the job itself. What is that job doing? So if I go talk to a specific Fortune 500 retailing company, they actually use Kubeflow pipelines with MLflow for metadata. And then if I go to another organization, they've built on top of Airflow, and they've kind of essentially recreated many of those similar hooks. So I see that over time, these pipeline orchestrators will be commoditized. It's really about the jobs themselves. I remember when I used to host the Kubeflow pipeline sessions at AWS, there were a lot of questions about like, how do you package these KFP components? Like, how do you make these jobs reusable? I think MLCtl built part of that bridge. And by layering the MLCtl with Baklava, you can also start creating the hooks into other services. So I think right now, model monitoring is picking up a lot of interest in Steam for a model server that is deployed into SageMaker. You can emit the metrics within the Baklava binary so that it's not handled by the user, the data scientists, ML engineers. It really provides this interconnection mechanism, and MLCtl acts as the orchestrator that can provision all these jobs and the configs when in runtime that then Baklava hooks into when it does that deployment. So it's almost like these two pieces all come together. We have some of the work done by this working group on model serving schemas. You have MLCtl doing the orchestration layer, and I expect that over time, some other standards, whether they be de facto standards through lazy consensus or through some more formalized discussions, can emerge in areas like feature serving. They all can cohesively come together in a unified experience. And with that, if there's no other questions, that's all I have for today's agenda. Stefan's traveling right now, so I don't think we have any updates on the test suite project yet.
Maybe, I'm not sure if you already talked about it before I came, but I know you and I have, but maybe if you can just talk about some of the maybe directional things you guys are thinking about compared to other people trying to build this control plane right now. So I guess Metaflow and maybe a few others who are maybe not so public yet, but what's kind of, or how are you thinking about differentiation? And, you know, what is, I know they're kind of being super gung-ho on SageMaker right now. And I didn't know you guys are already thinking about kind of beta versions for Azure and stuff too. So besides that, are there other things that you're thinking about?
So I won't speak for Intuit's roadmap entirely. I know that they built the tool really for their use case, and I'm helping them open source it and bring it to other customers because it's an evident and clear value prop. I think where Intuit's taking MLCtl versus what I've seen other utilities do, it's not about over-engineering. And it's also not about requiring enterprises take out what they have already. I think that's one of the challenges that we see in a lot of the startups today. It requires a lot of pulling out what an enterprise currently has and then plugging in a newer, shinier way of doing things, which I think for many startups is proving to be an okay business model. We're seeing a lot of good valuations that are helping these companies grow and scale in sizes and interest from the investor community. But at the same time, MLCutl is a testament that Intuit has a lot of legacy systems. They also leverage SageMaker. And there's a path forward where you can basically swap out the adapter, which has these plugin modules for other infrastructure backends. And with that, I think core differentiation here is really growing incrementally and solving each one of the steps where you can package using existing tools like Kubeflow pipelines, and then also reuse your existing component code. The mapping translation layer is not intended to create a whole new DSL. It's really about incremental baby steps that combine the experience together. And with that, enabling the infrastructure providers that are commonly used by prospective customers. This library and SDK is really intended for two suites of audiences. One that is maybe a startup or a smaller ML engineering team that may be already locked into one cloud vendor like AWS, but wants to bridge open source tools with managed services. The other user persona is the Intuits of the world, very large enterprises that want to not just leverage open source with managed services, they also look towards a prospect of going multi-cloud, where you have this whole larger sphere of on-premise solutions. You have like Azure and AWS being the two large cloud contenders right now. And then you have also these open source tools and libraries. And I think there's going to be a lot of interest around mixing and matching these different tools together. And just quick plug, I'm going to be doing a best in breed series on towards data science and Medium, talking about this whole idea of taking the best in breed tools, composing it together, and then also talking about model monitoring, model serving, and then the feature orchestration, and then probably data labeling as well. Telling the story of like how the different tools compare against each other, but also from a ML platform engineering perspective, like when is the right time to take the best in breed approach versus the end-to-end solution that you might get from a SageMaker. It's a conversation topic I've seen a lot of CIOs and managers start asking themselves to their ML managers and also their ICs. Does that help answer the question in terms of incremental, but also like really focused on taking the existing tools that enterprise has and then bridging it together rather than reinventing the wheel?
Yeah, no, it makes a lot of sense. It's nice that you're able to actually connect with these other tools, even though there may not be like a clear standard that everyone's kind of following for how to connect everything. Over time, are you going to start, because I know I saw Metaflow is starting to do this, but for experiment tracking, they'll let you hook up with weights and bias or MLflow, whatever you want, but then they start taking the best features out of all of them and kind of building that piece. Do you guys kind of see that happening, or kind of just let you connect with, for monitoring, you do what you want, Fiddler, Mona, whatever you want, and just stick to it at the layer level where you allow all these, adapters and connections to happen, but you're not necessarily building any one of these specific services.
I won't speak for Intuit and Srivathasan again. At least from where I see it right now, MLCutl aims to be a neutral library that does a lot of the interconnection. That may be something that they're exploring. I won't be able to speak to that. I think right now there's enough low-hanging fruit where just interconnecting all the different tools will already add a lot of value for enterprise ML platform teams. I don't think we want to own the horizontal the way that every startup is aiming for right now, or every cloud vendor. I think we see a very clear sweet spot where everyone's aiming to be a horizontal from the ML platform team perspective. We want to provide the interconnection layer so you can compose that horizontal any way you like. That's a great question, by the way. I definitely enjoy those type of like thoughtful strategy in terms of the direction of the library. Are there any other questions from others? Comments, feedback?
Yeah, I think as a quick question, did you know if there is like a similar recording for serving using MLCtl?
I don't think there is one made yet. I can ask Srivathasan, see if we can schedule time to package one together.
Got it. Yeah, sounds good. Yeah, it's just it would be great to see how, yeah, the whole end-to-end pipeline.
I encourage everyone here, if you guys are curious or want to engage in a deeper discussion, especially since Intuit's a very large enterprise that's doing ML at scale, you guys should reach out to Srivathasan directly, and I'll drop his email in the chat right here so that you guys can email him right here.
Yeah, no, I think that could be cool. So, did you see Intuit doing? I guess you've interacted more with them. Did you see them doing like another like kind of umbrella project, like the Argo project, but for MLOps?
So I think that's where they were going down originally. I think after several pivots and seeing where the ecosystem's going, they realized that MLOps orchestration is like a good medium. So Srivathasan's actually very closely tied with Alex Collins, who many of you might know from Argo Workflows and Argo CD. They're kind of like all tied to the hip together in terms of open source projects. This is not intended to replace Kubeflow, just to be clear on that. I think we see Kubeflow as essentially another version of SageMaker, where there's a horizontal and there's a vertical component for each one of those common pieces. So KF server for serving, you have KFP pipelines for the orchestration of workflows, and then you have various operators and notebooks. It's intended that mlctl essentially is the entry point to your different KFP and KF services. I don't see them taking Argo and essentially rebuilding all of the KFP ecosystem, although that might happen if we find that KFP v2 still has a lot of shortcomings, or their user experience, they really dropped the ball there.
Yeah, no, a lot of things like having mlctl, it could be a lot of value added on top of Argo workflows directly. That could be interesting. Yeah, no, sounds good.
Last round for questions or comments. Okay, thank you all for coming. Really appreciate everyone's feedback and engaging in this dialogue discussion. Like I said, really encourage everyone to reach out to Srivathasan in terms of if you're interested in partnering or learning about the utility or how Intuit does their ML platform. He was really excited to share this, and I think they'll be coming regularly to some of these discussions as we unfold more of the standardization practices within MLOps and the mix and match. And also, if anyone's interested in collaborating on the Best in Breed series, I would love to do a follow-up as well, just to help articulate some of these narratives around the tooling of the different stages of MLOps and how enterprises should think between the end-to-end ML platforms versus individual tools that are essentially independent of an ecosystem alone.
Are you going to pick specific tools for certain parts of the pipeline?
I haven't thought about that yet. You know, I go back to some of our chats about like, do we want to go sponsored approach versus just talk about the tools versus be tooling agnostic? I think my position right now is I'll actually plan to talk about tools and dive into the differences of features on a actual like rubric level. I think for a best in breed series, you just have to do that and you have to pick a side, but qualify that the sides might change very quickly given the evolution of the ecosystem.
Yeah, I think that makes sense. I think, if you just do the like monitoring what features you need, and not everyone will have all, I don't think anyone will cater to all of them. But yeah, it's like, I see too many articles where they talk about something and they list all 20 of them, and the reader is still just as confused, and it's on this, this grid table, but it doesn't really help. So yeah, I think best in breed would be nice.
So my plan is I want to talk to probably one vendor or one open source like creator, and then also talk to several DIY internal within enterprise and try and split the difference in terms of narrative of theory. and it helps evangelize all these different pieces. And I hope that those conversations can also like help bridge back some of our narratives around what does it mean to have like a common SDK or common schema that allows an enterprise to mix and match between what's available in open source or from a vendor and from their existing DIY solution. Part of that theory is, once again, people aren't going to unplug something that they've already built and invested in and go to open source or vendor. But if they can bridge that gap already, there's a path forward for portability. That's a really good nice to have. All right. Any other questions or comments? Well, thank you all for joining. I will upload the recording and send a summary out within the next day or two. Thanks, y'all,
Cheers,
for
Alex.
That's great.
Thanks, everyone.
Yeah.